Hello everybody, I'm back here with another video. This just has three problems, and these are very important questions because they're taken from an exam that I have just given. Let's look at these questions, and this is for college physics, but it might help university physics students too. So here is the first one. In the first one, a ball is thrown horizontally from a point 24 meters above the ground, strikes the ground after traveling horizontally a distance of 18 meters. With what speed was it thrown, assuming negligible air resistance? First up, the ball was thrown horizontally, and it was from a point 24 meters above the ground. And third quantity there, it strikes the ground after traveling a horizontal distance of 18 meters. So this diagram explains everything. So you have the 24 meters and the 18, of course not drawn to scale, and the ball is thrown horizontally from there. So let's mark those 18 meters, that's 24. VOX is what we are trying to find, because when it's thrown horizontally, it only has a horizontal velocity. It does not have an initial vertical velocity, which means the initial vertical velocity is 0. You got it. So VOX is what we're trying to find, but we know that VOY is 0. The acceleration in the y direction is negative 9.8 meter per second squared. What happened there? Okay, and then acceleration is negative 9.8 meter per second squared. Do we know delta y, which is the vertical displacement? Yes, we do. Delta y is negative 24 because it's going down. It's negative 24 meter. Can we find the time? Do we know the time? We do not know the time, right? We do not know the time. Can we find that time? Yes, we can, because you remember this equation, delta y is V naught y t plus 1/2 at squared. If you use that equation and plug the numbers into it, you're going to get negative 24 is equal to half times negative 9.8 times t squared. Half times negative 9.8 is negative 4.9. Divide both sides by 4.9. So on the right side, you have t squared. Now find the value of t. You get t as 2.21 seconds. Now what do? We know that it took 2.21 seconds to hit the ground. And we're also given the delta x. We're given the delta x, which we have not used. So that's what we're going to use now. The time that we found and the delta x, which is given, we're going to use that in this equation, because we know that the horizontal velocity never changes. It's technically V naught cosine theta, but theta here is 0, and cosine 0 is 1, okay? All right, cosine 0 is 1. So that is our VOX. That is our VOX, remember. So we plugged in the time, which is 2.21. We know that the delta x is 18. Do the math. You're going to get V naught as 8.13 meter per second, which is 8.1 meter per second. I hope that makes sense. So see what we did. We used the vertical displacement to find the time, and then use that time with the horizontal displacement to find the horizontal velocity. All right, let's move on to the second one. Here is the second equation, second problem, I mean. A cat leaps to try to catch a bird. So the cat is, of course, on the ground, and it leaps at an angle of 60 degrees off the ground, and its initial velocity was 3.48 meter per second. What is the highest point of its trajectory, neglecting air resistance? So we'll start off with the diagram. So that's the velocity of the cat. That's not the path taken by the cat, but that's the initial velocity, the direction, which is 3.48 meter per second. That is the ground, and the angle is 60 degrees with the ground, right? Now that's the path. I've not drawn the complete path because we don't need to. We just need to find out the highest point. So delta y is the highest displacement, or the biggest displacement, delta y. And we're given this velocity as 3.48 meter per second. So you break it into its components. You're going to get the horizontal as V naught cosine theta. V of x is V naught cosine theta, and V of y is V naught sine theta. Right? So let's focus on the vertical quantities. Now V of y is 3.48 sine 60, which is 2.82 meter per second. Now, do we know the acceleration along the y direction? Yes, it's negative 9.8 meter per second squared all the time. Do we know the final vertical velocity at this point? Yes, we do. It is 0. Now, remember, I'm not saying that the velocity at this point is 0, but I am saying that the vertical component of the velocity at the highest point is always 0. That's an important point to be noted. So now can we find delta y? Yes, we can. We have this equation. V final squared is equal to V initial squared plus 2a delta y. So once we plug it into that equation, you get 0 is equal to 2.82 squared plus 2 times negative 9.8 times delta y, which we are trying to find. 2.8 squared happens to be 7.95, and then 2 times negative 9.8 is negative 19.6. Switch sides, rearrange, calculate carefully, and you will get the value of delta y as 7.95 divided by 19.6, which happens to be 0.40 meter. Okay, another choice. Okay, this is choice that's the closest. So in multiple choice, you always have the answer that is closest, which will be right. So voila, we got this. That's number 2. Let's move on to number 3, okay? Here is the third question. You throw a rock horizontally again. You're throwing it off horizontally off a cliff with a speed of 20 meters per second. Again, no significant air resistance, and after 2 seconds, the magnitude of the velocity of the rock is closest to. Now, the word magnitude means you just need the value of the velocity. You need not find the direction. You need not find the angle. All right, so we need to find the velocity after 2 seconds. Do we know the initial vertical velocity? Yes, it is 0 because it's thrown horizontally. So we know that the initial vertical velocity is 0, don't we? Okay, here is the diagram that shows the horizontal velocity of 20 meters per second. And this is the path taken, and here you see now that the horizontal velocity never changes. So the vertical velocity initially was 0, but because of the gravitational attraction, it's going to keep increasing. And after 2 seconds, the vertical velocity becomes something. So once we get that, and we know the horizontal, you find the resultant of the two. All right, let's do it. Let's find the vertical velocity after 2 seconds. So what do we have? Do we have the initial vertical velocity? Yes. That's 0. We're looking for the final vertical velocity. We know that the time is 2 seconds because it's given in the problem. We know the acceleration is negative 9.8 meters per second squared. You know, when you take down the terms, you should be able to make out which equation to use. In this case, it is V final is equal to V initial plus A times T. And you plug the numbers into that equation. Now, I'm not even writing this because that is 0, okay? So it's A times delta T, which is negative 9.8 times 2, which is negative 19.6 meters per second. So once you have that, so that is now 19.6 meters per second, and this is 20. And you see a right angle triangle right there. And you know that this is going to be the square root of the sum of the squares. The square root of the sum of the squares, which gives you the answer. 20 squared plus minus 19.6 squared is 28 meters per second. So that's how we do this. Thank you for watching. Please don't forget to share these videos because it might help somebody down the line. Thank you again.